individual. Tommy, I know you're out there, and I appreciate what you do for electrical safety, so thank you. And I had to get on this here because I know I am about 30 minutes late for my Q&A Friday, which was supposed, I'm actually 44 minutes late. I was on a GFCI task group. I'm chairing a Coeur d'Alene Committee task group for the 2023 code cycle, and it ran over, so I apologize. And then this week, Monday through Thursday, I was at NTI, National Training Institute, and I was teaching on Codes and Practices 3 and 6, a curriculum, and we were talking overcurrent protective devices. We were talking about what circuit breakers were, what fuses are, the time current characteristic curves. Had a great class, 2 classes, one in the morning, one in the afternoon, and that was Monday, Tuesday, Wednesday, and Thursday. Got back late last night. And I'll tell you what, there is a big difference between presenting to a group of individuals who just want CEU credits and presenting to individuals who don't have to be there and are there to learn. Because we had some really good dialogue this week and great questions. Steve Froming in the house. Yes, I will. Going long anyway. I don't know. I'm going to try to keep this one short because I got to look at when I don't even know when my next meeting is, which I think is relatively short from now, Steve. But I was up in Michigan at NTI in Ann Arbor. We had some classes, and I was doing a technical. We were talking codes and practices. We were talking about overcurrent devices, the proper application, sizing of your overcurrent device, selecting the conductor, doing your ampacity calculations, picking your overcurrent protection. What is 80% versus 100%? Interrupting ratings, short circuit current ratings. What are the differences between those? We went over what a circuit breaker is, what a fuse is, what a time current characteristic curve is, how to do selective coordination, how to estimate your short circuit current ratio or short circuit current ratings, all that great stuff. It was just really good. We had some really good questions. And a gentleman from Alaska there, look what he gave me. He gave me an Alaska plate. Look at that. I mean, it's green, so it's kind of hard to see, but I got that. I got some pins. I made some good friends, and we made some new contacts. So it was really cool. Tamaki Ono. Hey, wait a second. What is this? I got to do a close on this. Tamaki says, I'm sorry I couldn't attend many important live streams since my internet environment had been so bad. Sorry. Hey, Gustavo. Everybody out there on the Technical Social Distancing Network, Eaton's Tech Talk. It is Friday. I'm wearing my weekend shirt already, and I'm ready for a great weekend. And Felix Sandoval, always good to hear from you, my friend. So today's Q&A. So this is Q&A Friday, and what I want to do, hey, Nihad El Sharif. Yes, I know it was delayed. I had Tommy on the phone, and I just talked to him. He's making headway. So this individual is very passionate about providing protection for those who have access to and can open disconnects that don't have a dead front. I know you've all seen those, as I have, where you open the door and there's a disconnect there with no dead front, and he's seeking to get a lock required on the cover. And I think he's making headway in the National Electrical Code. He's definitely ruffling some feathers in the standards worlds. And if there's anybody who is deserving of a $141, I would say Tommy Davis might be on that list. So anyhow, I am going to be scheduling with a session with him. I'd love for you to feel his passion, hear his passion, because it is very motivating. And I love passionate individuals who express their desire to increase safety in the industry. Sometimes we may not be right in our journey is, but you know, as I do, when you live in the codes and standards world, you have an idea, you have a concept, you think you are absolutely right, you start bouncing things off of people, and sometimes you are 100% right. Sometimes you may shift off of where you were going a little bit, but it just gets better. So anyway, I want to get to questions. And tell you the truth, I have not prepared because I was on calls all morning and I was in class all week. But I'm going to take a look at what we have coming in on YouTube. So let's take a look together. Let's see. JW is out there. Felix. Okay, let me look down here. Does anyone know a 3? I already answered that one. There's my buddy Felix. Tried to find a good JW. JW says, tried to find a good 210 related presentation for this, but couldn't. And this was my Q&A Friday. So he's responding to a Q&A Friday. The text in 210.8D says 210.8D. Let's take a look. You got, and I know you're not, you don't jump on this phone without your code book, right? So we're going to go to 210.8D. And look how well worn 210.8D is. I even got a broken page here. 210.8D says, unless GFCI protection is provided in accordance with 422.5B3 through B5, the outlets supplying the appliances specified 422.5A shall have GFCI protection in accordance with 422.5B1 or B2. Well, let's just read what he says. The text in 210.8D says GFCI protection shall be provided for the branch circuit or outlet supplying the following appliances rated 150 volts or less to ground and 60 amps or so less, single or three-phase. Question about this language. The protection is required to be provided for the branch circuit or outlet. It doesn't say that the outlet shall have GFCI protection. Is someone to conclude that the 4 would mean the GFCI protection be ahead of the outlet and not just at the outlet? It says it's being provided for the outlet. All right, let's just answer that one first. Remember that the GFCI protection, when we say in 210.8A, we say all 125 volt through 250 volt receptacles installed in locations specified, right? And anywhere where we talk about, A was not a good example. Let's pick another one. In accordance with equipment, GFCI protection shall be provided for receptacles required in 210.63, right? The 4 would mean GFCI protection, and what he was saying, shall have GFCI protection. Shall have GFCI protection. Trying to find the shall have GFCI protection. 125 volt branch circuits rated 50 amps or less, 3-phase in the locations, shall have ground fault. Okay, so what JW is references is in 210.A and B. It says, like in A, it says all 125 volt through 250 volt receptacles installed in the location specified in A1 through 11 and supplied by single phase branch circuits rated 150 volts or ground shall have GFCI protection for personnel. That is a little different than saying an outlet, because I don't remember when I say an outlet, there's nothing in there. If I put a receptacle in that outlet, it becomes a receptacle outlet. If I put a lighting fixture in that outlet, it becomes a lighting outlet. When I just say outlet, in many cases, when you look at 210.8 and he's referencing D, which is appliances, they could be hardwired and there is no receptacle. So the language that we use is saying that that protection is for that outlet. That means it has to be ahead of the outlet. That means that either you could go to a receptacle, come off the tail of the receptacle and feed an outlet that feeds an appliance. I don't see what would be wrong with that. And the GFCI or the GFCI device that could be ahead of that other outlet that could provide GFCI protection. It could be a blank face GFCI. It could be a receptacle type GFCI, or it could be in the circuit breaker. But it does have to be ahead of the outlet. And we use that same language in C, where it says crawl space lighting outlets. GFCI protection shall be provided for lighting outlets not exceeding 120 volts installed in crawl spaces. So you put that in front of the lighting outlet. So yes, and when it says, in his question, it says the protection is required to be provided for. It doesn't say that the outlet shall have. Is someone to conclude that for would mean that GFCI protection be ahead of the outlet and not just at the outlet? I would say yes, because if you put GFCI at the outlet, what are you going to put it in? You're going to put it in some sort of device, which now it becomes a specific type of outlet. And that's not what we're talking about. So hopefully that makes sense to you. And then JW went on to say, isn't the reason for the rule concerning over failure of the appliance? And if so, what is the reason for requiring the protection ahead of the outlet? I think this could cause a problem because putting GFCI device closer to the equipment that it protects is said to reduce the chance of nuisance tripping. And I would disagree with that. Well, I think I know where you're going there. You're going with the fact that if you have multiple appliances, the leakage currents could add up. So putting GFCI protection closer to that device could reduce the likelihood of nuisance tripping. And I would argue that I could reduce the likelihood if I provided an individual branch circuit for that appliance. If I'm worried about leakage current and the addition of leakage current for an appliance, which is in the list items there, which, and it references 422.5. So let's take a 422.5. 422.5. 422.5 says automotive vacuum machines, drinking water coolers, cord and plug connected high pressure spray washing machines, tire inflation machines, vending machines. So if I'm worried about the accumulation of leakage currents, now the other thing I could put those ahead of the outlet. Now hold on. Where the appliance is a vending machine is specified in A5 and GFCI protection is not provided in accordance with 422.5B3 or B4, branch circuits supplying vending machines shall have GFCI protection in accordance with B1 or B2. So here's the other thing too, JW. And this is a struggle, and I would agree with you that there is language, and because we are making changes to this section as part of the 2023 cycle. And I would say that the 422, the 210.8 section did change too. So you can go out and look at the first draft report for 210.8. And you'll see that we made significant changes to that section. And I am going to try to find it for us because this is I'm going to look at the first draft report, which everybody can do. So everybody can see the first draft report. 210.8 says, drum roll please. 210.8 says, we have A, we have B, we have C, and D, specific appliances. We say now GFCI protection shall be provided for the branch circuit or outlet supplying the following appliances rated 150 volts or less to ground and 60 amps or less, single or three phase. Automotive vacuum machines, drinking water coolers, cord and plug connected high pressure, tire inflation, vending, etc. So we made a change to that, and we used similar language that we did for lighting outlets. GFCI protection shall be provided for lighting outlets not exceeding 120 volts installed in crawl spaces. Now, to your point as well, for outlets, are we saying that if you have a cord and plug protected tire inflation machine, does it have to be in the circuit breaker or can it be in the receptacle? And that's a good question. Let's think about that. The way the language is stated. I see your point. I see your point. I see your point, and I look forward to your public comment, because what I would suggest you could possibly do is we would have to do some reworking of D. We would probably have to do some reworking of D to address some of the way that language is, to account for a receptacle that is supplying one of these appliances shall be provided with GFCI protection. So in any case, I think you're making, I think, I understand what you're saying. I get what you're putting down. And I think that maybe there is some clarity we could add to that section of the code. Putting the GFCI, so it's not enough. Yeah, so what I'm glad you're online, JW, and you're chatting up a storm. That's kind of cool. I'm aware of the difference between outlet and receptacle. Well, that's a good thing. So if it says for outlet, then a GFCI receptacle is not allowed because it must go ahead of it. And you know what? My point is that if you put a GFCI receptacle in there, then it's no longer just an outlet. It's a GFCI receptacle. It's a receptacle outlet. You haven't provided GFCI protection for the outlet. You've provided protection for. Boy, this is a deep question. I think it would be hard to find if you had a cord and plug connected device and you put a GFCI receptacle in that outlet and you're supplying it, a cord and plug connected tire inflation machine, I think you would be hard pressed to find an inspector that would say you're not providing GFCI protection for the outlet because you put a GFCI receptacle in it. It became a receptacle outlet and it has GFCI protection. But if you hardwire that appliance to an outlet that doesn't have a GFCI receptacle, then it still needs to be provided GFCI protection for that outlet. So I think you're covered both ways. That the language for the outlet, if you put a GFCI receptacle in there, you're providing GFCI protection for the outlet because you've turned it into a receptacle outlet with GFCI. If you don't have a receptacle in there and you hardwired to it, then you have to provide GFCI protection for that outlet, which will have to be upstream, either in a receptacle or a blank face device that is providing that protection, like a wiring device or a circuit breaker. So, and I agree, we use that term in multiple locations. So there's other situations where it says for, like in bodies of water. Let's go back to bodies of water. We can take a look at that. If you have a section reference, I'd appreciate that one. Intended to mean that putting a GFCI receptacle at the outlet is not enough. So if it says that the GFCI protection is required for the outlet, installing a GFCI receptacle there or hardwiring the appliance into the outdoor GFCI enclosed breaker would be a violation. We could have a debate on that one. First time listener, hey Amar Gopinath, thank you for joining us. Virtually gas, natural. Question for me is, what are some of the common electrical concepts I should know for my upcoming interviews? And I'll talk about that, Amar. If you hardwire it to an enclosed GFCI breaker, then no GFCI protection is provided for the outlet. An enclosed GFCI circuit breaker, if you hardwire it to an enclosed GFCI circuit breaker, if you have an enclosed GFCI circuit breaker, it's a listed product. So it's no longer an outlet, right? To an closed GFCI, an enclosed, I think you're saying enclosed GFCI. So I think what you'd have to do is go through the code and really look at everywhere we use the terms GFCI protection for. Well, no, an enclosed GFCI circuit breaker is not an outlet, right? An enclosed GFCI circuit breaker is a listed assembly. I would not be permitted to make my own enclosure and mount a circuit breaker inside of it. An enclosed GFCI circuit breaker is a listed assembly. Now, if I had a blank box in the wall, that's an outlet. But if I have an enclosed circuit breaker, it's a panel board. What's it listed as? And if it's not listed, then I would say you might have other issues because the AHJ is going to tell you you made a homemade enclosure. That how are you going to show that it meets the requirements of your SCCR ratings, your clearances, all that good stuff. So I wouldn't go there, JW. I would go back to just a blank box in the wall and look at all of the different areas of requirements. And if you have the bodies of water reference, I'd appreciate that, so we can take a look at that language that you're saying would only, that their intention is to have it ahead. But I think you bring up a really good point that we really have to look at when we say provided for, as opposed to the language that we find in 210.8a that says shall have ground fault protection for personnel. I'm not sure if I'm answering your question, but I don't think I can, because I think we really need to look at everywhere it's used and then sit down and make sure that we're using those terms correctly and come to consensus. Because in many cases, the language, if it differs from place to place, we need to look at that and as a committee come with an agreement on the proper interpretation of that, because now you're getting a little bit into more of interpretation. But and you're right, it does need to be clarified. It really does. I'd have to take a look, and I know Nihad's probably listening to this as well, and he's on panel 2. We could have that discussion. I'll bounce that around off of people, maybe a few other inspectors, on what their perspectives are. Do they share your perspective on it? I like it. I like the discussion. So now what I'd like to do is just really quick before I go back over here, and I know I'm going out of order, but Amar is live. So he says, first time listener, I really appreciate you joining in, Amar. So thank you very much for that. Question from me is, what are some common electrical concepts I should know for my upcoming interviews? So Amar, I would say you have to really look at where you're at. Like what are, I'm not sure of your background, and I don't know if you had sent me a note. But you say your first time. So I would suggest, if you are an electrician, then the National Electrical Code is very important from an installation requirement, proper use of the products. So you want to be a qualified person performing if you're doing an installation, you need to be qualified on the products that you're installing in the system. So you're going to want to have good product knowledge. You're going to want to have good knowledge of the National Electrical Code, because you're going to be installing things to meet the National Electrical Code, or regardless of where you're at and what version of the NEC you're on. You have to understand all of that. I would say that if you would want to understand the fundamentals of short circuits, short circuit current ratings, the capabilities of the devices. So equipment has interrupting ratings from an overcurrent protective device perspective. They have short circuit current ratings from a capability of to withstand the current flowing through them. So voltage ratings, anything that has to do with a rating of a product that you're going to be installing. And if you're an engineer, you're going to be specifying. So we have to understand, if I have a corner grounded delta system, if I have a slash rated circuit breaker, I may not be able to use that. If I have slash rated equipment, I may not be able to use that in a corner grounded delta system. If you don't understand why, then that's a place you need to start, is understand the voltages between conductors based upon the type of a system: ungrounded, grounded, corner grounded, corner delta grounded, etc. understand the voltages in the systems, and then understand how to properly apply those products from a voltage perspective. Understand your current, any of the ratings of a device or equipment that you're installing. You have to make sure that you are applying that correctly. As design engineers, we need to make sure that we specify the right products. I would start with understanding the products and solutions and understanding the codes and standards that I'm going to be following in the process of installing equipment. That's if you are in the electrician side of the business. I would say even from a design engineering perspective, you need to understand those fundamentals as well. It's all about the fundamentals of power systems, analysis and design. If you have more information on where you're at in regard to the industry, I might be able to give you some more advice, but and I've got a lot of material on my YouTube site as well. But feel free to reach out to me. You can go out to thomasdimitrovich.com, and I have my contact information out there. So if you go to www.thomasdimitrovich.com, you can get more information about me and my contact information. Send me a note, send me an email, ask me some questions. I'd be more than happy. I try to take things as they come in. I'm a busy guy, and I just get hit from a lot of different angles. So I apologize if somebody has sent me an email and I haven't gotten to it yet. So Robert from Omaha, greetings and salutations. All right, so let's take a look. Let's continue our journey. For equipment not connected by cord and plug, this new rule is written would require that you close. So I think hopefully, I know you didn't get exactly an answer, JW. I agree with your thought process, and we should take a look at it. All right, Felix, hearing from Felix, giving you the thumbs up. There's a whole bunch of new requirements for over 1 kV proposed for Article 240. In many cases, they are duplicates of what is put in Article 225. 225 has language about requiring testing for protective relays. When we are nearly duplicating it in Article 240 with similar but different text, seems the committees should have conferenced on this before doing it. How might one point this out to NFPA in a way that doesn't require submission of a complete new draft as public comment on TerraView? Duplicate language can have a negative effect by making the code longer than needed and also creating the room for confusion due to slight differences in texts. All right, so JW, I would agree with you. The premise of 90.3 tells us that we should be, 1 through 4 apply generally, 1 through 7 can modify and amend each other. But I would agree there is an effort going on right now to try to consolidate things. I'm not sure of the bunch of new requirements in medium voltage in 240. We could take a look, and I don't know if you're speaking to the 2020 code. 2023 is what you commented on in the top 10 changes. Now, in the 2023 code, there was a correlating committee task group that looked at medium voltage. And I can tell you that their goal this cycle was not to create an entirely new bunch of requirements for over 1,000 volts. They are simply moving things to do, I think, exactly what you are intending in your statement. So that correlating committee task group is working to, for example, I'm chairing a medium voltage task group for 210 because we accepted the creation of a 231, and we are moving the medium voltage requirements out of 210 and moving them into 231 so that the requirements that we create in Article 231 apply to medium voltage and only medium voltage. So you don't have duplication in 210 and in 231, and we're making them stand alone so that you don't have to keep referencing back and forth. So I think, JW, the correlating committee task group and the task group work that I'm involved with as part of the correlating committee efforts are to do what you are pointing out. They're trying to remove the duplication. Now, there were some, panel 10 did not accept some of the changes that the task group on medium voltage proposed, so those did not go in. I would suggest go out and take a look at the first draft report and realized there is still committee work going on. But the task group was not seeking to add new requirements. They were simply seeking to move requirements, and they weren't going to try to address the technical issues with those requirements, because there is, for example, actually it's Article 245. Yeah, and I don't believe that 245 was accepted. And I'm looking at TerraView right now. Oh, 245, overcurrent protection for systems rated over 1,000 volts AC. So that looks like that did pass. Now, those are not new requirements. Yeah, so that Article 245 is not new requirements. They moved the requirements from elsewhere into this. At least that was, I believe, the intent of that task group. And if you look at the global FR that's associated with that, it says affirmative, negative. I'm looking for, it was a correlating committee task group that made that. The correlating committee accepts the action taken by CMP 9 to create a new Article 245 for 7940. FR 7940. Based on this action, the correlating committee relocates the overcurrent protection requirements in Part 9 of Article 240 to a new 245. As a result of this correlating revision, first revision 7940 becomes committee input 7940. Purview of this new article will be determined after the second draft. So what's happening, like in 210, we removed all the medium voltage stuff out of 210 and we put them into 231. So panel 9 should be removing medium voltage requirements out of the previous and moving that over to the new. So there wouldn't be duplicate. It would be a self-contained article. Also, article numbers ending in 5 for medium voltage. Now, Robert, I know where you're going with that. There was an intent to do that, but remember 215 is feeders, and that ends in a 5, but it doesn't cover just medium voltage. So that didn't quite pan out from a .5 ending in 5. And L says, we are using EYS fittings on non-hazardous locations with a sealant other than what is required by the manufacturer to mitigate the passage of airflow. Is it okay to use this fitting outside of its listing as long as it's approved by the AHJ? Well, L, I know this is not necessarily a medium voltage discussion, but just to address that, I would say, L, the AHJ can approve anything, right, that they want, but they're going to have to use something, in my opinion, to justify why they would be accepting it. What is an AHJ right now? If I make a Van Ducky and I say this Van Ducky is surge protection, and all you need to do is it's magnetic and you slap it on the side of your load setter and it works. And I say I want it to be approved. Now, an inspector could say, well, I'm going to improve it based on a conversation with me. I mean, or the inspector could say, look, I'm going to accept some liability here, possibly if I approve it. So they'll want to know, is it listed? And if it's listed, then they'll look at the listing and make sure that the listing says it's going to do what this guy says it's going to do. Then that gives them the ability to approve it. But, L, I would say the HJ can approve what they want to approve. They could get a field evaluation. They can do a lot of different things. They can accept studies from third-party organizations or others. And they can say, based on that, I approve it. But, in reality, the AHJ can approve whatever they want to approve. They're the AHJ. But I do believe they would have to take onus on that. So back to the medium voltage. Yeah, that's okay, Al. Back to the medium voltage, but that was a good question. And hopefully, let me know if you agree or disagree with me, really. I mean, my thoughts on the AHJ approval is they can approve whatever they want to approve. It doesn't have to align with the National Electrical Code. They just have to justify what they're doing, I would say, for their own protection, right? The reason we fall back there, for example, there is nothing in the National Electrical Code in the 2020 code and earlier that says a circuit breaker has to be listed. You could use a circuit breaker that's not listed. But That's what I would say. Oh, that's the consensus. So cool beans. Thanks, Al. All right. So now the code may. So back to medium voltage. We are moving those 245 overcurrent protection for systems. So they're creating this new article. What they should be doing is removing it from elsewhere in the code. So JW, what I'm seeing and the intent I understand is the first step of the medium voltage effort is to move things around. The second step, which will be in the second draft or the next code edition, will be to look at the technical content. Because I'll tell you, for example, medium voltage equipment is all 100% rated. There is no reason to do a 1.25 calculator on continuous loads. Yet, the sizing and whatnot still requires it, even for a medium voltage application, and that is not necessary because medium voltage equipment is 100% rated. So you would not need to do the 1.25 factors, but yet if you follow the National Electrical Code, you would have to do that in medium voltage applications. So we technically, I don't believe we can address that technical problem in the next cycle, or in this cycle, because it would probably be perceived as new material, but we would have to do that later. Now, and I say that, hold on. I do say, there's not a lot of areas. There are some instances, minor instances, where they have the 125%. But if you look at like 210 for feeders, we do say that you have an exception if it's 100% rated. And since medium voltage equipment is 100% rated, you can leverage the exception. So what I think you're going to see, at least what we did in 231, was we moved the requirements over just as they are in branch circuits. And you'll look at it and say, well, that is the exact same language that's over in 210.19. But I'm not going to necessarily, because I can still say that the medium voltage equipment is 100% rated and I'm going to follow the exception. But in the next revision of the code, I could delete everything associated with 125% and just make it very streamlined and clear exactly how you size the branch circuits, size your overcurrent protective devices for that protection after you do your load calculations, etc. So that's my thought process on that. All right. Are you live? James Smith, 1 week ago. Yes, I am, James. That's too funny. Anyway, hi, Thomas. Have just found your material. I'm not sure who that's from. On YouTube, and your explanations video are really fantastic. I appreciate that feedback. Thank you for sharing your knowledge with us all. Thank you. And remember, this is cross-pollination. We got some very smart people out there who are sharing their points too. So, and I appreciate all of that feedback. Top of the line content. Thank you, William Snyder. Thank you for that feedback. Thomas, is there a link to where you can? Okay, so this one here is there a link to where you did the calculations on the single line diagram you mentioned in the beginning of the video? And this is my power systems engineering, and there is. And remember, everybody out there, that if you go to my YouTube site, it's easier to find there. I have all of my previous, anything I live stream can be found at any time. And I created playlists. So I have playlists that basically, for example, I have a playlist for, I'm looking for it. There's circuit breakers, there's transformers, there's lighting, there's generators, there's fuses, welding, medium voltage, cabinet making, kitchen, coffee, Porter cable, panel boards website. I thought I had energy management, PPE. I don't have, well, go to videos. I'll create one for power systems analysis. But I have a video that does, and if you recall, I did it live and I did a hand calculation of short circuit currents. And I am going to find that one. And it was a live working tutorial. There it is. It was 4 months ago. Selecting the OCPD, selecting OCPDs and power systems engineering. I believe that was it. Fault current calculations. There it is, the lab. Fault current calculations lab. 5 months ago. I'm going to open this one and hopefully mute it really doggone quick. And I'm going to get the share and I'm going to put the link to it. Copy. I'm going to put the link here. Control V. And I'm also going to put it out there on that comment. I'm going to reply and put the link and say, here you go. Control V and hit reply. So that way, so I did a complete hand calculation using the per unit method for short circuit currents. And what we did was we created a small one-line diagram. And we created a small one-line diagram and we did a manual calculation on the fly. It was a lot of fun. I enjoyed that session a lot. So check that one out and put the link up there. All right. Thomas, we've done calculations. So I put that link. Password protected breakers. Is Eaton running into the same issue with a California rule prohibiting manufacturer default passwords, resulting in a customer wanting to send equipment back to the factory if they forget it? Well, JW, we have, yes, we have not, I'm going to say, yes, we do have products that have default passwords. But if you ever forget the password, you call our technical support and they will bail you out, because we do have other ways to get access into if you should forget your password. So I would suggest, and it wouldn't be the password, I wouldn't want to broadcast how we do that on my YouTube channel, because for obvious reasons. But we can help you work through if you lose your password and access into that device. There are ways around that. And I would suggest you get in contact. You don't have to send the product back to the factory if they forget it. At least based on the knowledge that I have. I hate to say you never have to, but I know based upon my involvement with those products that we've always had ways to do things as a backdoor that didn't require you having to take the product out of your switchgear and send it back to the factory. So I would say contact you can contact our Eaton technical support, and they will be able to help if that ever happens to you. But I have not I've not heard of a California rule that prohibited manufacturer default passwords. I mean, if we didn't have a default password, then how would you get into it? And if I didn't have other passwords that'll help me help you, how would we fix that? So that would be a problematic California rule. I'll do some homework on that one. I think the question the person asked classically is if turning the 2000 amp breaker down, oh, I remember this one, this was a good one, down to 1600 amps would make it meet exception 210.20 for 100% rated breaker. The answer is that it doesn't. That's true. It does not. And that's what I tried to explain. If I didn't come across that well, I apologize for that. The answer is that it doesn't automatically meet the exception if you seal it at 1600 amps. That is correct. It doesn't meet that. In fact, the National Electrical Code, if you follow the journey I took through the language, it would be clear that just adjusting it down and sealing it does not meet the National Electrical Code, period. The short answer is talk to the manufacturer. No, the manufacturer can't override the code either. So now the manufacturer should tell you, no, it doesn't, and that you need a 100% rated breaker for that application. But if the manufacturer erroneously told you, yeah, we can do that, then I would say you just follow the sections that I referenced in the code, because the code tells you you can't, regardless of what the manufacturer would tell you. But it is a good idea to always contact and leverage your manufacturer. As it is the assembly, all breakers in the assembly, as well as the breaker in question that have to be listed for continuous operation at 100% of its rating. That is exactly right, JW. A lot of people miss the point that if you screwed up, if you did your calculations, for 100% rated and then said, oh, I screwed up. Now I'm just going to change out a breaker. You have to change them all out. And you may have to change the entire enclosure out. For example, the moment you open that dead front, if you see aluminum bus, that panel board cannot meet the standards for 100% rated. The UL standard for panel boards tells us it must have a copper bus. And if you look at like my catalog or others, you'll find that the catalog will say you can apply this at 100% rated when the panel board has specific, say, high density copper bus. So it's not just a standard copper bus, it has to be high density copper bus. So I will tell you that some of my panel boards will not accept 100% rated breakers and to be 100% rated. It's all about the temperature. It's all about getting the heat out. And if I can't rely on the conductor that you are attaching to my lugs, my terminals, then I have to get that heat out in a different way. Maybe it is the copper bus that I mounted on in the panel board, right? Maybe it's different lugs. Maybe it's a different design of a device. But regardless, you have make a very valid point that it is not about the device. It is about the assembly and all of the devices in that assembly. Big mistake many people make. I'm going to say many people. Big mistake I have seen made in real applications since 125. So I'm not going to read all of what you said there, but I get the gist. Don't just trust the engineer on your job, however. Right. We all get things wrong. We all get things wrong sometimes. You're absolutely right. Notice the West Virginia IEI chapter that I think you are a part of has almost no events for the next several months. Are they really that inactive, or do they not post? So we do have a YouTube site. Oh, I'm not sure if you're talking about the YouTube site. We meet, the West Virginia chapter meets twice a year. We have 2 meetings in the spring, 2 meetings in the fall. That is when we meet. That's when we all get our CEU credits. So that's our schedule. So we don't meet every month, but we do meet in the spring and in the fall. So JW, that's sort of how we roll here in West, by God, Virginia. Thank you, Shemek Power, for your feedback. Per unit and short circuit calculations, how do you think the climate crisis will affect oncoming developments in Congress? Well, Elfie, I don't know. I'm not a political guy. I never talk politics. I try not to watch the news as much as possible. And I just focus on electrical safety. But I don't know how it's going to impact the developments in Congress. I can tell you state by state, we're doing a lot more in photovoltaics. If you look at like Cal Green out in California, they've adopted some requirements that require you to be PV ready, or actually California requires you to put photovoltaics on every roof, right? They're going to start requiring car charging spaces. Portland, Oregon, in Oregon, they're instituting laws that you have to be PV and EV, electric vehicle ready, in the structures that you build. So I think from a climate crisis perspective, I would say and argue that the states are probably doing a lot more. I can't say a lot more. I could say I see more activity coming out of the states, state adoption, than I see coming out of the federal regulations. So I would just say that, in my opinion, we're going to see a lot more electric alternative sources, wind, solar. We're going to be seeing electric vehicles being leveraged more. We're going to need charging. We need to work on the infrastructure. So, I hope somebody realizes that we're going to need to build our electrical infrastructure to serve all these electric vehicles. We may, we're going to need extra power. Either we're going to have to build power plants, or we're going to have to look at alternative energy sources, whether it be electric photovoltaics or wind or other hydro, whatever it is. We're going to have to be thinking about that to make sure that we can meet the demands from the industry. So thank you, Alfie, for asking the question, though. Hello, I just started my career as an electrical engineer. This is Natalio Ramirez, electrical engineer, and I'm struggling to understand grounding and earthing. Do you have any materials that might help me? I got just the thing. Oh, yes, I do. Hold on. I don't know what I did with it. Well, I'll tell you what it is. I'll tell you what it is. Here's what I'm going to do. I'm going to do this. We're going to do this one together. So let's go here, and we're going to go with PowerPoint. Yep. All right. So we're going to go to iaei.org. All right. So about the IAEI, education, members, resources. And if you're not familiar, if you're new to the electrical industry and you want to understand the code, you want to understand, this is an organization high on your list, in my opinion. It was high. It became high on my list the moment I learned about it because nobody told me about it. And then I started going to the meetings and I'm like, wow. And I started reading the books, right? So here it is, new IAEI, new member referral program. I'm not looking for the referral. I don't want $35, but join. I'm just happy to share the knowledge. All right, so you click on the store, and I'm telling you, this is probably the most inexpensive education that you're going to get around grounding and bonding and earthing. SOAR's Grounding and Bonding. Great book. This is the first thing you need to add to your library, in my opinion. The SOAR's book on grounding and bonding, 14E, that's the 14th edition, based on the 2020 code. It's only $79. And if you're an IAEI member, you get a discount. So consider joining the IAEI and purchasing this book. There are also online educational events that I would highly recommend. Online training, live online training. You can come down and look at all of these. Find the one that talks about grounding and bonding. I don't see anything right now online. 1 and 2 family. I don't see anything on this schedule, but that's the live events. So then you have the on-demand training, and in here you have analysis of changes, Article 310. You're looking for grounding and bonding. Look at this. SOAR's grounding and bonding, 4 hours, 8 hours. I mean, if you take a 4-hour course from these guys or 8-hour course from these guys, and you don't know something about grounding and bonding and earthing, we got other issues to talk about, buddy. This is a great reference for you. That's my recommendation. I will probably dabble on it on my program here on my YouTube channel. I know our engineering services may have, I don't know if you go to eaton.com/electrical worker training, we focus a lot on equipment. We focus a lot on the proper application of equipment. So I would complement that class on grounding and bonding, the SOAR's grounding and bonding, and that book with a look and a peek at this resource. And if you go to the Eaton electricaltraining.com, eaton.com/electrical worker training, and if you sign up for any courses, if you use the promotional code Eaton Tech Talk, all one word, EATONTECHTALK, then you can get a 10% discount on anything on there. So that's what I would point you to, and that's what my suggestion is. So that book, that grounding and bonding book, SOAR's grounding and bonding book, the greatest reference I have, and I just bought one. I just bought the latest version, but I have multiple editions of it here in my desk. And I've read them over the years. So that is a great reference for you. That is what I would suggest. So hopefully, and Natalio, I hear the other thing I would do. Here's another thing I would do. Watch right over here. Subscribe. I would suggest you subscribe to my channel. And remember, I'm going live as often as I can. You never know what we're going to talk about, and join in on the Q&A Fridays. Hopefully you'll get something out of that. Okay. Do you have troubleshooting videos for these transformers? And this is my 15-minute tech talk on 75 kVA transformer. And I'm telling you, that video is trending. It is trending. It's amazing how many people have watched that video. So you're going to want to check it out. When in doubt, check it out. Do you have troubleshooting videos? I don't have troubleshooting videos for that product, for transformer troubleshooting, but I'm going to take that under advisement. That maybe I'll try to get some transformer people online and we could have a troubleshooting discussion. Hi, Thomas. Thanks for the great video. Have any other studies done that you could share, please? I would love to understand more when using correct formulas at each stage. When you use cosine, sine, or inverse tangent, polar, rectangular along the way. If not a study, could you recommend some reading that would assist me better? This was on the fault current calculations lab. So here's my, and this is just as IA, so I'm not sure who that is. My suggestion, if you are getting into the calculations, the best references I can give you are two books. IEEE. I'm looking for, you can go on Amazon or you can go to, I'm doing a search here, Red Book, IEEE Red Book and IEEE Buff Book. Those are the two books from a short circuit calculation perspective. Those are the two books that I would reference for you. It's IEEE 242 is the Red Book, or I'm sorry, that's the Buff Book. So what you have here, oops, sorry about that. I don't know what the heck's going on. Oopsie daisy. Oopsie daisy. There we go. I'm back. So IEEE 242, IEEE recommended practice for the protection and coordination of industrial and commercial power systems. That is the IEEE Buff Book. This is a great reference for you. I would say this should be in your library. Also, 141, IEEE recommended practice for electric power distribution for industrial plants. I thought we called that the Red Book. IEEE Buff Book is 242. IEEE Red Book. IEEE Red Book is 141. That's what I thought it was. You can get it on Amazon. I don't know what they're going for on Amazon. Let's take a look. 88 bucks. Great reference. And I don't care what version you get. I look at the 86 or something like, or 91 version. I don't know what it is, but IEEE 141 or 242, a lot of what I did, all those calculations are in those two references. So this is what I learned from. I learned from the IEEE Red Book and the IEEE Buff Book. Two great references. Another one which can be pricey, if you can find it, is Beeman's Handbook. Beeman Industrial Power System Handbook. This is another really good industrial power systems handbook by Donald Beeman. I'm just going to go to the, this is an original. So this is the one I have. It says hardcover, 96 bucks. So look at this. The book outlines up to date. So this book, if you can get it at a good price, I mean, look, you could buy a new one for 494 bucks, 13 used at $93, 2 collectible from 153. So, you know, I would go for the used books because I wouldn't, you know, it doesn't matter if the cover is, you're using this to learn something from. So that is what I would suggest. That is a great, it was, mine's, yeah, mine is behind my sheet here, but the Beeman Handbook is, in my opinion, if you're a power systems engineer, you got to have that as well. It's old, but it is a book that is very very important for your background. I can hear on YouTube. Excellent. Tom's sound is good. You muted yourself. Uh-oh. I didn't mute myself. Did I mute myself? No, I'm good. Audio's gone. Please fix. All right. No audio anymore. Michael Meyer, L. Hopefully you got all that. So I wasn't watching. So hopefully you got that fixed. L. So, all right. So industrial power system. So those are my three for my calculations, understanding the per unit system, doing a short circuit calculation, using the per unit method, Buff Book, Red Book. And the Industrial Power Systems Handbook from Beeman is another good one. But a lot of pretty much everything you need to know, in my opinion, is in the Buff and Red Book. Those are my two that I would reference. And if you ever have any questions or any questions about doing those calculations, please let me know. I'd love to help you. Okay, can cable limiters ever be used to accommodate lower fault current ratings on equipment? Never seen it done this way, but wondered if it was allowed. I would think there would be a concern with parallel runs of making sure they all operate, both for purposes of clearing the fault and also to make sure you don't have just one open, creating overload on the other conductors if the circuit survives the fault and is re-energized. JW, great comment, buddy. I agree with you. So there's the challenge with a cable limiter. Think about, and if you're not, if somebody's not familiar with a cable limiter, cable limiters, I'm going to throw up a picture of a cable limiter. So these are the PowerPoint. What time is it? 1:45. I've been going for an hour, so I am going to have to, after this one, I'm going to shut down because I got another call coming up here shortly. So we have cable limiters. Now, the thing with a cable limiter and where they're used most often, you think about a utility supplying power. They don't just put a cable limiter at one end of the cable. They put it on both ends of the cable. When you have multiple strands, so what will typically happen is you have a fault in a cable. That means your conductor is toast. It's gone. It's done. It fails. The limiter is there for cable protection. So they're sized based upon the conductor as well. You select them based upon the conductor size. You'll notice that there's one terminal, and they are this side right here is landed on the equipment, and this side is crimped onto the conductor. And when the conductor, or if the conductor fails, this limiter opens. And what would typically happen, it'll probably open on both ends, okay? Because you think about it, if you have a fault in the center, you have at the source, it will open. You'll have current flowing through, like say there's 4 conductors, right? And I'm protecting on both ends. And this conductor fails. I open this side, but then these 4 will serve the fault back down and through, and then I'll open it on the other side, and I isolate one of the conductors. So because of that, if I have clear the fault, and to your point, if I have 3 conductors and I only clear one, then the other 2 still are providing current. Can I really leverage that for a short circuit current rating? I would say no. In my opinion, because of what you pointed out, that would be an issue. And what I'll probably do is, I might do is I'll do a program on current limiters to help us understand how you size the current limiter, how you pick the current limiter, how you install the current limiter. And I do have a video on the proper installation of current limiters for cable limiters. Cable limiters. Replace the current, I was saying in the last minute, with cable. It's cable limiters. Okay, that is going to bring me to an end. And I know I didn't get through everything, but I got through enough. Hopefully you got enough to chew on for next week. Join me next Friday for a Q&A Friday, and I will be going live Tuesday and Thursday, I believe. So please hit the thumbs up, and don't forget, please don't forget. What am I going to tell you not to forget? Subscribe. Do me a favor, hit that subscribe, hit the bell. You'll be notified when I go live, and you can always access these later. And it's free from me. All right, everybody, I have to drop off. I got food sitting here, and I got a meeting in less than 10 minutes. Thank you for what you do for the electrical industry. Thanks for what you do for electrical safety. Thanks for all of those. Michael Meyer, JW, Elfie Burgess, Felix Sandoval, Robert from Omaha, Al Teresi, Felix Sandoval, Robert from Omaha, JW, all you guys, and Steve Roaming in the house. Thanks for joining in, Gustavo. Take care, stay safe, and please, by all means, stay healthy. Until next week, have a great weekend.